Hi, my dear. Uncle Demi. Here I am. How are you? My dear, continually chapter 11, watershed management, part C, runoff. Generally, when precipitation occurs, part of it will be absorbed by the ground and lost by deep pressure, while another part intercepted and depression by the vegetation, in addition to lost part by evaporation. On the other hand, the remaining accumulation part overflow at high velocity toward ditches, reservoirs, lakes, seas, and or oceans at surface or subsurface flow, which is known as runoff. Taking consideration that using the term runoff is usually meaning surface runoff. Look, my dear, catchment area at British terminology is the area which always contribute and catching surplus water runoff. Taking consideration that the American usually using watershed as an absolutely term instead of catchment, as shown in the enclosed figure. Factors affecting runoff. Really, there are many factors affecting runoff, such as precipitation, watershed characteristics, land topography, geological feature, meteorological data, vegetation cover, and human activities. Number 1. Precipitations. Rainfall duration, intensity influence the rate and volume of runoff, as total runoff for a storm is clearly related to the duration for a given intensity. Logically, soil infiltration rate will decrease with time in the initial stages of a storm. Thus, a storm of a short duration may not produce any runoff, whereas a storm which has the same intensity but for long duration usually causing a runoff. Look, my dear, watershed characteristics. Runoff from watershed depends on size, shape, and topography of its area. As example, a case of long narrow watershed fern leaf shapes, the tributaries and streams are generally have different places and connecting the main stream at an irregular distance, and so the runoff intensity should be less. Conversely, a case of wide band shapes, watershed, the tributaries and streams have the same sizes approximately, in addition to overflow at the same time on the main stream, which is meaning has high runoff intensity. Figure showing different shapes of catchment or watershed area. Look, my dear, it is so easy, as explained before. Look, my dear, topography features such as slope of upland area, degree of development, and gradient of tributaries and streams extend, and number of depressed areas also effect on rate and volume of runoff. Moreover, soil characteristics play also an important role depending on its both infiltration rate and water holding capacity. Look, my dear, meteorological data. Really, runoff intensity is affected also by the prevailing climate conditions on the catchment area, such as temperature, wind velocity, and humidity. Also, vegetation and agriculture practice influence on runoff intensity, as vegetation retarding water flow and so increasing the storage capacity of soil, which effect on reducing peak of runoff rates. Also, human activity as hydraulic structures such as culverts, bridges, reservoirs, and barriers have a significant influence on runoff rates. Estimation of runoff. Really, there are different methods which can be used for estimating runoff and overflow, such as empirical formulas, volumetric estimation, and stream flow. Number 1. Empirical formula. Really, it is important to calculate the expected runoff rates for achieving the purpose of designing and erection the required hydraulic structure, as shown in the enclosed equations and table. Look, my dear, this method is considered sufficiently accurate for estimating runoff in the relatively inexpensive structure design. Look, my dear, table showing runoff coefficient values of rational formula. Koch's method. Really, runoff was established by Koch and originally developed by as Soil Conservation Service as requiring some assessment of main factors affecting runoff, such as vegetation cover, soil type, drainage, and slope, which is arithmetic sum of these factors, as shown in the enclosed table. Moreover, runoff coefficient is the relation between runoff and rainfall intensity and can be expressed as shown in the enclosed equation. Table showing Koch's watershed characteristic values. Moreover, table showing the estimation of Koch's values of runoff according to watershed area and watershed characteristic values. Look, my dear, runoff coefficient depend logically on all factors affecting runoff and can be obtained from the enclosed table, which showing various runoff coefficient percentage and its correction factor at different rainfall seasons and watershed classes. Look, my dear, number 2, volumetric estimation. Really, it is important to estimate the total volume of runoff which may become from a watershed that known as water yield. Volumetric estimation mainly depend on recording rainfall, stream flow maps, and data in addition to watershed soil characteristics, and consequently can be done by different methods such as mass rainfall infiltration method. Normally, soil infiltration rate under rainfall beginning rapidly depending on soil characteristics, which is known as instantaneous filtration rate. Hence, consequently start for decreasing gradually with time, reaching to an constant rate, which is known as basic infiltration rate, which is average rate defining by W index. Look, my dear, any excess of rainfall than 0 point will be considered theoretically equal to surface runoff, and its duration is also known as effective duration, which consequently can be estimated as shown in the enclosed equation and figure also. Figure showing the estimation of runoff by rainfall infiltration method. Basic hydrograph method. Really, this method is based on developing a design hydrograph from basic hydrograph as shown in the following steps. Follow it, my dear, by yourself. It's so easy, as shown in the enclosed figure. Plotting a basic flood hydrograph with presentation and relation between flow against time, as shown in the enclosed figure. My dear, developing the design hydrograph from the basic hydrograph by using a conversion factor, as shown in the enclosed equation. Look, my dear, on the design hydrograph, 1/100 of the peak flow times 1/100 of the runoff duration should be equal to 1 fascia of the flood volume, just as on the basic hydrograph, as shown in the enclosed figure. Soil Conservation Service formula. Really, it is shown in front of you, my dear. Follow it by yourself, taking consideration that S values are shown in the enclosed table. Runoff nomograph method. It is a quick method for estimating runoff from a small watershed area, taking consideration that values of runoff coefficient is shown in the enclosed table. Figure showing nomograph for estimating runoff of small watersheds. My dear, follow the example shown in front of you. It is so clear. Runoff zeros method. Really, it is known also as alternate method for estimating runoff depending on the effect of different variables in the watershed and defined also by U.S. Soil Conservation Service, as shown in the enclosed table. Table showing runoff curve numbers according to the different variables of watershed area. Figure showing runoff curves, showing the relation between runoff and rainfall under different runoff curves number. Moreover, there are many practical methods which can be more and used for measuring the runoff flow in streams by determining the mean velocity by different methods which explained before. Estimation of soil losses. Really, estimating soil losses is more difficult than estimating runoff, as there are many variables influencing this process, such as soil type, degree and length of land slope, cultivation cover and its rotation, fertility, rain duration and its intensity, soil erodibility, and conversion fraction. Accordingly, there are several appropriate models used for different regions, such as Browning equation, as shown in front of you, my dear. Follow it. It is so easy and clear. Figure showing different soil erosion factors curves according to Browning's equation. Runoff control. Control of runoff from sloping land should be done in a controlled manner to lower area from dissipation its flow energy. Accordingly, it is important to erect some control structure of runoff to intercept the development of water flow and decrease its velocity, which consequently protect the cultivated area, roads, and farm buildings from damage, in addition to diversion water pathways to ponds, safe outlets, and or reservation structure, such as ditches. Really, there are many types of ditches differ on each size and width, depth, length, shape, and construction used material depending on the main purpose of installation. Waterways. Really, it is necessary under large runoff volumes to supplement waterways to carry and conducting the largest charge of runoff from terracing system, contour furrows, different ditches, and emergent spillways to reservation ponds or protecting area, as shown in the enclosed figure and table. Figure showing cross sections and dimensions of different waterway shapes. Look, my dear, an important table showing shapes, protection media, flow velocity, slopes, and use conditions for different types of waterways. Dykes and water barriers. Really, it is a type of protection devices against runoff flow, and many consist of high pans constructed by using either the natural soil materials or other locally housed strange materials such as gravels, pebbles, ballast, or stones. Goodbye.